So it's summertime. Right now it's a nice like 70 whatever degrees on a Saturday morning. And summer's normally the time for... That guy just made a U-turn. Summer's the time for people to go outside and enjoy themselves. And one of the things that I think is most fun to do during the summer is to play a nice little game everybody likes to call it catch. Now, what is catch? Well, catch is a game that you play with somebody else where you have a ball and the other person is standing really far away directly in front of you, or off to the side or whatever if you want to make it harder, but I suck at catching. And the whole object of the game is you take your ball and you throw it and you hope the other person catches it. And that's basically it. It's a pretty simple game. The thing that I wanted to talk about are the benefits that I think catch has. And one of the benefits I think it has, it's really bright now, is the idea of social interaction, and how catch is one of the first ways little kids first begin their journey of interacting with other people. And the other idea that I've seen catch brought up in is in the idea of building physical strength. Now, people in their like 20s and 30s aren't going to go play catch to like build better biceps or whatnot, but they've done studies apparently with like elderly people. So what they've done is put elderly people on like a metal balancing plate that measures their center of mass or their center of gravity, and they put a harness on them just to make sure they really don't fall, and they kind of just start lobbing heavy medicine balls at the people, hoping that they don't fall. They realized more and more as they kept playing back and forth with the elderly people that their balance would improve and the motion of their center of gravity became less and less because they were balancing better. So that's like two completely different ways that catch was able to improve the lives of people. So then I started thinking, well, I'm sure I could use catch somehow to explain a physics concept, and thankfully enough I did. So I'm gonna add a third way that catch is able to improve our lives through an intellectual means. Here's the game I present to you. My game is still catch, but it's a little bit different. Instead of keeping them just flat, not moving, we're gonna start to rotate them. Kind of like we're gonna rotate them on a platform. And then when you do that, how does the game of catch change? So that's what we're gonna find out. What are you doing today?
Being really hot.
All right, take this. And then go sit in that chair over there. The question is what if I took a game of catch and put it on a big spinning disc? So spin as fast as you can and lightly throw the ball and pay attention to what happens to the ball. So what'd you see? It keeps like curving, right?
Yeah.
Spin the other way. And then lightly throw the ball at your hand.
Oh my god, it went the other way.
Yeah, right? I want you to just give your best guess as to what you think's going on.
I mean, I don't even know.
So now the question is, do you want me to tell you right now, or do you want to wait till the video comes out?
I kind of want to know right now.
Okay, I'll tell you right now.
Okay.
But I'll tell you guys in my room. So now that we're finished playing outside, and we know how the game is supposed to change, let's try to figure out why it changes in the first place. And to do that, we're going to set up a nice game of miniature catch. So in this game of miniature catch, we have two Mickey Mice. We have a red Mickey Mouse and a striped Mickey Mouse. And then we also have a little paper tennis ball that they're going to get to throw around. And they're all three sitting on this turntable right here. This is what I was imagining when actually coming up with the question, but I obviously don't have the capability or the time to build a life-size one of these for us to spin around in. To first start off, like we said, we're just going to start getting everything rotating, hopefully at a constant speed. And then whenever the red Mickey Mouse is ready, it's going to throw. So let's say it throws right here. Once the ball gets thrown, we have to realize now that it's no longer feeling the force that's causing it to spin in a circle. The only force it's feeling is the force of gravity, pulling it towards the earth. So this means that when the ball gets thrown, it's going to continue to travel in the direction that it gets thrown at, right towards where the striped Mickey Mouse is. If we're going, we're moving, and then he throws the ball right here, the ball's going to go straight. But we have to realize that these two are still rotating. So the ball gets thrown, it goes straight, but striped Mickey Mouse is still going and going and going. Once the tennis ball gets to where striped Mickey Mouse used to be, well, striped Mickey Mouse is all the way over here now because it was still spinning. So this is why from the perspective of the camera that we had outside, it looked like the ball got deflected either to the left or the right. But in reality, it's not some magical force that's pushing the ball to either side. It's the idea that when the ball is traveling in the air without feeling any force except for gravity pulling it down, it wants to go straight, but the table is almost just taking the target away from the tennis ball itself. That's why this works. It's not that there's completely brand new physics that arises because we're spinning on top of a disc. It's the fact that physics is a little bit different if you're working in a reference frame that's accelerating. The reference frame looking top down isn't accelerating at all. It's completely stationary. So we can see physics 1 concepts coming out. But once you put yourself on this disc, it looks like magic almost, but it's not. It's just working with different reference frames. So then this brings me to my final point. So this physics phenomena is called the Coriolis effect. It's the idea that if you have some reference frame that's rotating, like a turntable for example, and then you have some velocity within that frame, like the tennis ball, then you're going to seem like you're being pushed by some imaginary force, which is called the Coriolis force. Now, I know the question you might be asking yourself is, Dylan, when am I ever going to be playing catch on a turntable? Or when am I just going to be in any rotating reference frame whatsoever? And my answer would be, always. The Earth is a rotating reference frame. It has an axis and it spins along that axis. If you're moving at any velocity whatsoever on Earth, you are experiencing a Coriolis force. Now granted, for most everything, it's a really, 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 really small amount. You have to be moving pretty quick or be really, really huge to have any effect because of how big the Earth is. But there are some pretty recognizable things that the Coriolis force affects. For example, hurricanes spin because of the Coriolis force. It's the reason why they spin counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. Another one are ocean tides. If you have a lot of water moving at really, really high speeds in any hemisphere, they're gonna be deflected by the Coriolis force. With that being said, everything has a Coriolis force, which really just means that every game of catch you were playing is always just a little bit harder than you intended to make it. So thanks for watching.